Solve the triangle. A is 12 inches, B is 17 inches, and C is 25 inches. Well, very clearly, this is a side-side-side triangle, and I'm just looking for all three missing angles. So I'm going to start just by drawing a diagram. The side-side-sides are the hardest to get to any sense of real scale since I don't know any idea about what the angles are. So just doing my best here, right? I have a 12-inch side here across from A and alpha, a 17-inch side here across from B and beta, and a 25-inch side here, the biggest side across from C and gamma. Any diagram will work as long as the correct angle is across from the correct side. Well, I'm going to use the law of cosines to find my first missing angle, and I'm going to pick the biggest of the angles to start with. Because inverse cosines range is 0 to pi, it can give me an obtuse angle. It will tell me the correct angle regardless of whether it's a first quadrant or second quadrant angle. So the angle across from the largest side, gamma, is where I'm going to start. So c squared is equal to a squared plus b squared minus 2ab, cosine of the angle I'm looking for, gamma. Well, I have values to plug in for a, b, and c, so that would just leave me gamma to worry about. So I have 25 squared is equal to 12 squared plus 17 squared minus 2 times 12 times 17 cosine of gamma. All right, well, 25 squared is 625. And then I have 12 squared plus 17 squared, and that's 433, minus 2 times 12 times 17. 2 times 12 times 17. 408 times the cosine of gamma. And what I have in here is just a regular old trigonometric equation to solve. So I'm going to take 433 away from both sides. Divide both sides by that negative 408, and it's at this moment I know gamma really is an obtuse angle, because it tells me that the cosine of gamma is minus 192 divided by 408. All right, inverse cosine of that. And that tells me that gamma is about 118.1 degree. So I found the largest of my angles. And now it doesn't matter which angle I find next because I know they're both acute. I could use the law of cosines again. I have enough information for that. But I always find it easier to use the law of sines next. So I'm going to focus on finding alpha next. And I know the sine of 118.1 degrees is equal to this ratio when I divide it by 25. Weird way to say that. Sine of 118.1 degrees over 25 is equal to the sine of alpha over 12. All right, multiply both sides of that equation by 12. And I'll know what sine of alpha is equal to. Inverse sine tells me the acute angle I'm looking for is about 25.1 degrees. I know two of the angles, so I can find the third by just taking away their sum from 180. And that tells me that beta, my third missing angle, is about 36.8 degrees. All right, there is the unique solution to our side-side-side triangle.